Okay, so go ahead. What is the last thing that you guys heard? I'm not exactly sure when it cut out.
Is he frozen for you guys too?
Great. Can you guys hear me at all? Okay, so let's go ahead and try this for the third time. Um, what's the last thing that you guys heard when I was going over this?
Like when you started talking about the class declaration.
Like this part?
Yeah, all the way at the top. You started bugging out right about there.
Oof. Okay, I made it all the way down here, but that's okay. We can redo this. Um, okay. So yeah, let me know like if possible as soon as you guys can't hear me. If it happens again. So
Yeah, I think we all just assumed that it was one of us and not you.
gotcha.
Yeah,
Okay.
I
Okay.
think
Yeah. Just letting
um,
everyone know my internet's real shit right now. So you're welcome to interrupt me if you guys can't hear me. So um, okay. So class declaration. Okay. So line 6. This would be considered a class declaration. This is something that just doesn't have a definition associated, right? Um, on the other hand of that, you actually have a definition. This is when we open up brackets, and you're actually able to define what your class is doing, right? So that's the two differences there. Um, this is the same thing for functions or variables. If you don't have anything either set equal to or opening brackets, that's just going to be a declaration, right? Um, going into the actual class itself, um, classes are going to be defaulted to private. So basically, if you don't give it a public or private, like explicitly, it's just going to be private. Structs, on the other hand, those are going to default to public, right? So here we have a couple of variables, and we've just gone ahead and set some to private and just set some to public. All three of these would be, and the setter would all be like kind of accessors. You're accessing some piece of data. The getters are going to be getters specifically, and then the set name would be a setter specifically. So those are kind of the different types of functions you have. You also have behavioral functions or just behaviors. That's going to be a function that does something either with the data or gives some kind of like data back, but it's not as simple as just setting or getting some piece of data, right? We have the constructors. So you can have two options for how you want to do your default constructor. One can just basically take in no parameters, and you can just define how the default values of your variables are going to be. The other option you have is something like this, where you're able to actually set like the variable names themselves inside the parameter list. So this would set the private name equal to like NA, for example. So this would also be considered some type of default constructor. It becomes not a default constructor if like any one of these, so age for instance, no longer has a default value. That's going to basically um, make this no longer a default constructor, and this would just be a normal constructor. Uh, so you can only have one default constructor, but you can have as many normal constructors as you want. Obviously, you can only have one default constructor because the you know compiler needs some type of default to rely on. Having more than one just doesn't really make a whole lot of sense.
I thought that doesn't work. I thought that doesn't work though. Like if you make one parameter default and the other one's not, does that work? Like does
Um,
it compile?
I actually don't know if it necessarily compiles or not. I just know that like this wouldn't be
Yeah,
considered a
it wouldn't
default.
be
I mean I can run it real quick and see what it does. Um, but within, let's see if I have a definition for this. This would be in the CPP. Yeah, let's go ahead and see what this does. I think I have this one in. I'm trying to find out where I actually use this class. It might just be called main. It's not person. Nope. Give me a second while I try to find it. Guess I could just make a main in here. We'll just do. Nope. There we go. Okay. Yeah, here we go. Yeah, let's just compile this real quick. So we got main. So the stuff in here in main is going to go ahead and use, I think, that constructor. So this would be the default constructor. So this, I think, I'm not in the directory. Okay. Yeah, so this one, yeah, so this looks like it's pissed because we basically took that off. Missing argument for parameter 2. Yeah, especially because this is looking for a default constructor that we basically have messed up by taking this away. So there might be some way to get this to compile, but you might have to explicitly call it like this and make sure that things are being passed in. But yeah, we can't rely on that being a default, mainly because this is gone. But yeah, so it looks like you were probably right on that, because this got pretty pissed that I was trying to run it that way.
Makes sense.
Yep. Okay, so for the destructor, well, big three, there is the destructor, the copy constructor, and the copy assignment operator, right? So anytime we're using dynamic memory within our class, you're going to want to use the big three, right? If you don't use the big three, if you don't explicitly define a destructor, copy constructor, and copy assignment operator, you're going to have memory leaks. You're going to have your copy constructor and copy assignment not working correctly, where it's going to try to do a shallow copy. And when you do that with pointers, basically two instantiations of the same object are going to be manipulating the exact same pointer value for whatever private piece of data they're working with. And that's not really the behavior we want within a copy constructor and copy assignment operator, right? We want those to be two independent instantiations and not sharing any type of data. So to kind of make that work correctly, we need to define all three of these things out, and we need to do it in a way that is doing a deep copy as opposed to a shallow copy. So that's kind of what we have going on here. The destructor is relatively straightforward. It's just going to delete whatever dynamic piece of data you have going on. The copy constructor, this needs to copy it again in a way that is a deep copy. So a shallow copy is specifically a member to member copy. So that's what all this stuff is. Doing a shallow copy with something that isn't a piece of dynamic memory is totally fine. You're not going to run into any issues, but we do need to do a deep copy when it comes to working with dynamic memory. So this ID number, for instance, is pointing to some new piece of data on the heap, and we need to go ahead and make allocated new location for that piece of memory. So that's kind of the job and the goal behind these copy constructors and copy assignment operators. As far as the syntax goes, make sure that you understand all the syntaxes and what the different syntaxes are between a copy constructor and a copy assignment operator. Going over it, a copy constructor, it's just going to be the name of the class that you're working with. So student in this case, it's a constructor. It's not going to have any return type. The parameters, you're going to have a const student. So we pass it in const so we can't manipulate what we're trying to copy. If we're just trying to copy from it, there's no reason we want to change it, right? And then we pass a reference in there just so it has like that actual object. And so you guys know copying by reference is a lot quicker than copying by value or passing by value rather. So doing this just is going to save a little bit of time, right? As far as the copy assignment operator goes, this is not a constructor, so we are going to return something. We need to return a reference to whatever we're creating so that whatever is receiving this reference can actually manipulate that actual object as opposed to some copy of it. The name of the function you can think of it that way, is that it's just going to be operator and then equal symbol. This is also an example of operator overloading, right? So we can do this with any type of operator you think of, like the plus, the minus, anything like that. We can go ahead and overload this. The parameters are going to be the same. I think I messed this up. This should, I think, be a reference. But the parameters are going to be the same as the copy constructor. We're going to pass in a const reference of another class that we're trying to copy over. So yeah, that's all that I think. Any questions about class stuff? I think this is the stuff you guys.
So I'm clear, the only reason you'd want to implement the big three into any class you decide to develop is if you want the memory of set, if you want to work with memory in set class with like dynamic memory stuff.
Yeah, if you're doing dynamic memory stuff, you're gonna want to use the big three. So if you're not doing anything with dynamic memory, there isn't really any reason to explicitly make these things because they're implicitly made for you, and they're probably doing the same thing. You're just gonna type up. So
But it's
like,
using pointers though, right?
say it again.
If you're using pointers,
hmm Um,
then you would want to implement at least like the copy constructor.
if it's using dynamic memory, yes.
Oh, okay, okay.
Yep. Yep.
So okay, so the only example I can think of so far with the dynamic memory stuff was the linked list lab we did, and that
Yep.
was because we with those classes we wanted to actually delete the members of that class because we wanted to. I'm a bit confused. Sorry.
No, you're okay. Yeah. So in the linked list, if we think back that because that's an excellent example for these things. If you think back to the linked list, you were creating a new node every time the user was like basically putting in a new element into the list, right? You would basically make a new node on the heap. So our destructor, if we just take a look at that individual component of the big three, we needed to go ahead and actually delete all of those nodes, right? So your destructor, if you guys did the project, went through and actually looped over your list and deleted each individual node. So that's the kind of stuff that the destructor is responsible for. If you also think of your stack and queue, your ABS and ABQ, you probably had a destructor there as well that went ahead and deleted your array that you used as the backing data structure within your destructor. For the copy constructor, kind of a similar thing with the dynamic memory, where if we look back at the linked list, you had this linked list that had a bunch of different nodes associated with it, right? And to properly copy that over, you couldn't rely on a shallow copy where you just copy it node by node, because all those pointers would be pointing to the same nodes, right? You'd end up with what seems to be two different instantiations of a list, but both of those lists would be kind of manipulating the same set of nodes, right? So we had to do a deep copy within our linked list copy constructor and actually create as many new nodes as like the old list had that were copying. So they're like completely separate, totally new pieces of memory that's on the heap to create that new linked list. And that's kind of what the copy constructor did. Did that kind of answer your question, or do you want me to go a little bit more on that? Okay.
It was good.
Okay. Cool. Yeah, good questions, guys. Anything else on this stuff? Sweet. Yeah. So I think the last thing I was going to say was just kind of touching on some of the questions that basically if you aren't dealing with dynamic memory, you don't need to actually explicitly create these, because what I have like right here, it basically is going to do for me. Like it does the shallow copies implicitly. But if you do end up explicitly making them, you have to explicitly define each component. Like just because it was implicitly doing this doesn't mean I can leave this out and think it's going to take care of it for me. Now that I've defined my own, it's going to default to whatever is in here. So you also need to make sure you're still doing whatever like shallow copies are necessary. So it's not that like shallow copying is inherently bad and never works. It's just inherently bad and never works for dynamic memory. Okay, so that's kind of an important distinction to understand and make.
Real quick, like just like a basis question, because
Mhm.
dynamic memory, that just has to do with when you're allocating memory on the heap, right?
Yeah, exactly. Yep.
Just like by declaring a pointer, by creating a pointer, that's not dynamic memory, is it?
Yeah, you're right in that. So the relationship I like to think is a pointer doesn't need dynamic memory, but dynamic memory needs a pointer.
Yeah.
Mhm.
But then in that case, let's say you have pointers in a class, wouldn't you need the big threes if you're trying to, for example, copy one instance of a class to another one, because if not, it will create shallow copies. So in that case, you do need
Um, yeah. So if you're saying I have a pointer that's pointing to something, it depends on You could be right. It depends on what you're doing with the pointer. If you're just copying the like the value of the pointer, like if you dereference the pointer and just copy the value, that can be done in a shallow manner. But if you need it to point to the same object, then there's not really any kind of copying you could do that could make that work. So I still think this only needs to be done using dynamic memory. So let me kind of draw this out, and then definitely tell me if I'm not like on the right page here. And then
Yeah.
definitely tell me if you think I'm wrong on this. Because
Yeah.
so the idea here, if you what you're saying is, so we're just totally scratching out dynamic memory, right? And we're just dealing with pointers.
Yeah,
Um,
we're just doing pointers. And you have
okay.
like, yeah, you have a pointer in one class
Yeah.
that points to like an int, right? But if you're creating a copy of that class, you don't want that copy, everything else to have its like same, to have basically be copies, and then the pointer in the new class
Mhm.
points to the same memory address of the original class. In that case, you would need a deep copy. If not, if not, you know what I mean? Like, if not, like,
I hear you. I hear you, and I think let me draw this out and tell me if this makes sense. And I could probably write some code that will hopefully make this make sense. Because I still, if I'm understanding you correctly, I don't think we're gonna need um
Mhm.
copy constructor. So if you have just class 1 and class 2, so let's just say you talked about an int pointer, right? So we're going to have like a int pointer in both of these, right? Because they're of the same class, right? They're just two different instantiations of the same class. So they both have an int pointer on their stack, right? So all variables are on the stack. So the variables are going to be sitting on the stack. Let's say we booted up the instantiation of class 1, right? Of this initial object, and you're saying that it's going to point to an integer, right? So we have some integer over here that is still on the stack, because if it's on the heap, then we're talking about dynamic memory, and that's not what we're doing here. So this is going to point to here. Are you okay with this model? Like, do you agree with what I've drawn?
Yeah, yeah. And then you
Okay.
basically make C2 equal to C1.
Um, yes, but here's the thing. So in the copy constructor, it depends on what we're actually doing with the pointer. Do you just want the pointer to have the same like value? So let's say
Yeah,
this
it's the same
integer.
value. It's just supposed to have the same value, but not point to the same address.
Yep. So what we can have is, what you're going to do is just dereference when you're doing the copying. Um, So when you dereference, would you agree that when, and maybe this is the distinction we need to make, but would you agree that when we like instantiate a new object like this, it has room for an int pointer on the stack within that object?
Yeah, if it's right.
Yeah, right.
Declare,
Yeah, exactly. So when we are going to do the copy constructor, we're going to do that copy constructor. We can do it in a shallow way, and that's because we're going to copy it. We're just going to dereference the integer. So we're going to
yeah,
say,
yeah,
hey,
yeah,
like this integer here,
yeah, yeah, yeah. You
that's
just
that's
pointed to.
that's pointing here. We're just going to dereference this and make this dereferenced copy.
Yeah, yeah, yeah. I get it.
Yep.
Like but yeah. So my question, I guess, was more like, you can't. It won't be implicitly. Is implicit like, um,
Oh, that's a good point.
yeah,
Yeah, because we're still saying we're writing it out, and the whole
yeah,
purpose of
yeah,
this
yeah,
is that we
yeah, yeah.
don't need to. Implicitly, I guess I'd have to write that and figure that out. I
Yeah.
want to
'Cause I
say,
feel like implicitly, it will just
yeah,
do member by member copy, and if it's doing a member by member copy, then theoretically, it would point to the
right,
box.
right. Yeah, that's a good point. It actually might do that.
But in that case, then you'd have to at least do like one of the big three,
Yeah,
and then you have to do all the
yeah.
big three.
Let's go ahead and write that out real quick and see what happens. Because yeah, you definitely might be right on that. So we're gonna go ahead and just nuke this copy constructor, just so that's going to be implicit, right? If we go up here, I won't use the ID number because that's using dynamic memory. Let's just make another int pointer and just call it like test pointer. And then in the constructor of student, let's go ahead and set this test pointer equal to a value of 10. Okay. And then within the main, let's go ahead and just make our own stuff here because I have no idea what's going on in here. So we're going to make a student, and then we can do Trevor. This we'll call the default constructor. So this is just going to go ahead and give Trevor's like pointer value a value of 10, right? And then we can basically instantiate this is going to be the copy constructor. We can do something like this, and then we can go ahead and print out both of their test pointer values, right? So we can go ahead and dereference this. And then do Brad. And then the whole idea here is that if we change Brad's test pointer to be 12, then both of these, if it is doing a improper job of copying implicitly, both of these will be 12, right?
Yep.
Okay, cool. Let's go ahead and run this. And it yelled at me because I did something dumb. It's yelling about the constructor. I think I may have messed something up with it. Don't know. Go ahead and clear these drawings real quick. Let's go ahead just for the purposes here. I'm going to go ahead and just do a default constructor here. Just because we don't need any of those parameters. So let's go do, just because they don't matter right now for this purpose. Obviously none of this makes sense. I don't care about that. We really just care about that test pointer. So let's try this again. Oh, I'm dumb. I think I commented out the main in undefined references student. Why? If you guys can see what I'm doing, that's dumb. Let me know. Because I have what I think is the default constructor here. It's scoped out. What am I doing wrong? Oh, I know what I'm doing wrong. Okay, I didn't. So, dumb mistake. You need to compile every single piece of, source files that you have, and I wasn't recompiling the student, so that's what happened there. Okay. Okay, so we get this just because I'm calling it delete, but yeah, that looked like that's exactly what happened. So, I think if you are just using a pointer, you are going to have to use some kind of copy constructor. So yeah, I think you're right on that because this both changed to a 12. Even though I was just changing Brad's number. So what that would mean is you would have to write your own copy constructor here that basically dereferences them in the correct way. So yeah, you're right on that. Where you would do test pointer equals old student dot test pointer, the dereferenced of that. Then I think this should fix that issue. Or give us a seg fault, one of the two.
So there you dereference. Okay, yeah. So you're setting the value.
Okay. I think I'm getting the segmentation fault just because I commented some other stuff out. But this should go ahead and give us what we need. Because here, this is where we're going to basically dereference it, is right here. Where you're dereferencing the old test pointer or the new one that you have, and you're just saying, hey, it's going to be whatever this dereferenced is.
Yeah. So
Yep.
just assign value to it.
Yep. But yeah, it looked like you were right on that. So that was a good question, and thanks for bringing that up. So it looks like if you're just using pointers themselves, which definitely goes against what, obviously I was preaching to you guys about how it's only when there's dynamic memory, but it also seems to be if there's some pointers involved. And truly the reason is that it's a problem with dynamic memory is because dynamic memory inherently uses pointers, which clearly, based off of our discussion here, that's actually the root of the cause, right? The root of the problem is really the pointers. So I guess be wary of that as well. If you're using pointers, you're going to have to make some kind of copy constructor, unless I'm doing something incorrectly that I'm over here that I'm not aware about. Then yeah, you would need some type of copy constructor to make sure that something like this doesn't happen. The only thing I can think about here that would argue kind of against what you were saying is still the case maybe if doing a shallow copy like this, if the whole point, because the whole point of a pointer is to store a location in memory, right? So if you're making two copies between two different objects, if both of those objects are still pointing to the same piece of memory, weirdly, that actually might be what you want if the whole purpose was to store a location. The difference with the dynamic memory is that the purpose of the dynamic memory is really to store something on the heap, but not necessarily store an address to it. So I think when it comes down to this might be more of a design issue, right? Because clearly, if we just wanted to store an integer, doing so in a pointer based on this is kind of a convoluted way of doing it, right? So I think maybe this actually comes down to more of like a design thing. And it's like, do you actually want both of these objects to point to the same location? Because once again, that is the purpose of a pointer, right? I don't know if that argument makes sense. But
Yeah.
yeah.
Thank you so much.
Yeah, no problem, man. That was a excellent question. So, okay, cool. Let's go ahead and move on. We can go ahead to, let's see what's next on my list. Okay, so we did class stuff. And then let's go ahead. We did big three. And then let's go to the next, in my opinion, like the biggest piece, which is just like pointer stuff, which just based off of the discussion, we've actually done a decent job of going over some of the highlighted material. So in this one, we'll do kind of the idea of pointers and then passing by reference and value, right? Because that's super important. So I kind of actually fit a lot of stuff into here. So let's focus just right here. Just in this self-contained like 3 lines right here, that's just normal declaration stuff. Here is like a pointer. So you're doing int star x is equal to the reference of y, right? So anytime you're declaring a pointer, it's super important that you set it equal to a reference of some value, right? And then down here is where we have a reference. So with the reference, basically int reference z can't exist by itself. You actually need to set that equal to something. So we could have like an x here, and then we can dereference or just set x equal to the pointer. But what we can't have is something like this, and then just doing z equals, because this right here, because z is like a reference symbol, it like doesn't have the memory by itself. Like it's basically just giving another name for a same variable somewhere else. By doing this, you're not putting like any memory on the stack or anything like that. So like int z like literally can't exist or do anything. So this is just like incorrect syntax. And you actually need to go ahead and set it equal to something already in memory. Where pointers don't have that issue, because doing something like this will give you space in the stack to set up a pointer.
I got a question.
Yeah.
So is this being recorded? And will we be able to access it? Where will we access it?
Yeah, it's on my YouTube channel, which I can go ahead and send you guys in the chat real quick. Yeah, if you guys have something to do or this is taking a lot of your time, I can go ahead and just dump this in the chat real quick. Give me 1 second. So let's see here. Okay, yeah, it should be here along with pretty much everything else we've done. This is the lab section I record, so if you guys go watch it, it'll be like the same thing that you guys like showed up for. But yeah, for anybody who like this is taking a while, a lot longer than usual, you're welcome to dip out and go watch the recording later. So if that's what you want to do. Okay, cool. So let's see here. So that's kind of the pointer stuff. And then with the passing by reference and value. So let's look at a couple ways that that works. So we have three different functions here, just foo, and then foo2 and foo3. So foo, starting with this one, if we take a look at that up here, we can see that it's going to take in a reference very similar to what this line looks like. So basically int reference param is going to be set equal to y. So when we alter what param is, that will actually change the value of y. I can probably change this to a 20. I'm not going to run this because I think you guys have seen this before. But then foo2, this is also passing by reference. So both of these are considered pass by reference. This is just passing in a different way. So this is going to go ahead and take in a pointer. So we actually need to get the address of y. And then because param is a pointer, we need to dereference the parameter to actually change anything about it. So I think I've said this to you guys before, but this right here is a much more C way of doing it, like the programming language C. And then C++ introduced this way, which is, in my opinion, and I think a lot of people, is a lot more cleaner to actually pass. You don't have to worry about giving this a symbol down here in the parameter, and you also don't have to really worry about like dereferencing or anything like that. So foo3, this one is going to be passing by value, which is when you actually pass a copy, it's going to make a copy. So anything that we change in foo3 isn't actually going to change the parameter that's being passed in. So again, it's not that this is necessarily wrong or you don't want to do this. It just depends on the use case, right? If you're trying to pass something in and you actually want it to change, then definitely don't pass it in this way because it's not gonna, right? You need to pass it by reference. Passing by reference is also a lot quicker. So copying a value is really, computationally intensive, especially if you're passing in entire objects, which a lot of the times you are. It's got to copy all of that object information, right? Which is going to take a lot more time than just passing an address and being like, here, go find the address or go find the object yourself, right? Any questions on pass by value, pass by reference? Usually where this will come up in the exam is just you understanding when you're looking through code that he has you look at, being very vigilant and knowing, is it being passed by reference or is this being passed by value kind of thing? Okay. So the next thing I kind of wanted to show you, and I will run this. Let's see here. I think that isn't as important. Okay. Okay. So here, what I've done down right here is going to be some like dynamic memory paired with like, obviously deleting this dynamic memory out. So if we take a look at this, obviously because we're not calling any type of delete, this is going to give us an issue, right? So this is going to give us a couple memory leaks, so we can take a look at that. Oops. Okay, so do Valgrind and then the pointer example, and then leak check equals. Okay, so this gave us like 120 bytes that were basically leaked from this, which each integer here is each integer here is 4 bytes. So I think this is telling me I've leaked like 30 integers. I don't know if I ran this incorrectly. I was also confused in my other lab because based off what I've done here, I was under the impression, I guess this isn't a double for loop. So I think that this right here is just going to be I should probably explain the syntax here. So this is attemptively a two-dimensional array, which I think this is what I meant to do, where this was going to be an entire array as well. Let's see if this does what I think it's going to do. Okay. 480 divided by 4 is 120. Okay, so this is a 2D array of size like 10 for the initial array, and then we're going to loop through here and basically add 10 elements to each element. I think I'm doing something wrong in here because I expected 4 bytes per integer times 100. So I was expecting just 400, but we get like 480. So there's probably a little something extra I'm doing in here. But the real purpose of this is understanding how to delete this. So just calling delete on this dynamic array right here isn't going to be sufficient. We actually need to go into the dynamic array and also delete all of these news that are happening. So if we take a, go ahead.
Real quick, I think I missed it because I had to go to the bathroom real quick. But the double asterisk after int, what does that mean? Is that like it's a vector and then it dereferences at the same time?
Yeah. So are you talking about this line right here?
Yeah.
Yeah, what this is attempting to do is actually make a two-dimensional array of
int pointer.
dynamic array. Yeah, a two-dimensional dynamic array. So I think this is just the syntax for it, where it needs to be a double pointer, and this is going to basically make a what's inside of here is new int pointers. So it's going to make 2 new int pointers in here. Is the idea, and then we can loop through all 10 of those and then create like basically create an array inside of each element inside the. So this is how you would do a dynamic 2D array.
It creates 2 pointers to dynamically like to 2 pointers to dynamic memory where like of contiguous memory basically because they're arrays, right?
Yeah, this double pointer is just needed to have to have like memory inside of memory. It needs to be a double pointer, a pointer to a pointer. Yeah, because
Okay,
the
so
outer pointer is going to point to the arrays on the inside.
So it's still firstly just pointing to one block of memory in the heap. Or is it pointing to blocks of
Yes,
memory?
yeah. So like basically, let's see if I can draw this out. The best I understand it. So you like dynamic memory, clear like obviously that like variable that's on the stack, the variable name itself, right? So that's over here on the stack. So dynamic array is over here on that's supposed to be a D and an A. And that's going to basically point to all of this new memory that is continuous memory. And in each 10, I'm not going to draw all 10, but all 10 of these are int pointers. So inside of here is an int pointer. And this int pointer is going to point to their own arrays themselves that are also going to be on the heap.
Those int pointers themselves, right? Are they in the heap or are they in the stack?
They're in the heap. Yep, because we use the new keyword on them.
Oh, so when you use new,
Yep.
does that mean pointers themselves are stored in the heap, or I thought it points to memory in the heap?
Because of what we're doing here, the actual integers are in the heap because we're calling new on them.
But when you usually do it, like when you just have int dynamic without the double asterisk, you will have a pointer pointing to memory in the heap.
Yeah, dynamic array. Yeah, dynamic array. That's on the stack. So this is the stack, and dynamic array is on the stack. Yep.
Okay.
So yeah, each of these, and so this is actually good that you have me draw this out because the whole reason this isn't going to work is because you would just be deleting this, like you delete this through, but you wouldn't be deleting any of these that have been made. Okay.
You'd have to do like a deep delete. It's like a destructor, basically. You need
basically a destructor. So we need to go ahead and make a for loop that's going to go ahead and delete each of the individual elements. And now this needs to be a delete array because each element in here is also an array, right? So let's go ahead and see if this works or if I mess something up. Okay, cool. So we get 0 blocks. So no more leaks happen. Now that we've gone ahead and deleted all the stuff. You still also need to delete these. So you need to delete everything on the inside, and then you also need to delete the outside as well. So if we went ahead and ran this, we would still get a memory leak in here as well. So any questions on this? Okay. The main takeaway isn't so much like the syntax, although it's probably helpful to know. It's just understanding that anytime you're deleting like a 2-dimensional array that is dynamically allocated, you can't just rely on deleting the like outermost form of it. You need to go ahead and delete everything on the inside. What you don't need to do is if this was just like a normal, like what we're used to, and we went ahead and made just a normal int array and just set that equal to a new int of size like 20, let's say. Doing this right here is perfectly fine. This is going to delete everything we need it to. We don't need to go in and delete each individual integer. The only reason we need to go in and delete each individual thing in the array is because it's in an entire array itself.
Yeah, yeah. So in the new example there you have arrays in the stack, and
Yep.
it points to a contiguous block of memory in the heap, basically, right? Because that's how arrays work. But and then you can just delete it because that's how you can just delete arrays like that.
Yeah.
But the other one, the other one, dynamic arrays in the stack, but it points to an array in the heap. No, it points to an array which is an array, right? Yeah.
Mhm.
Okay.
Yeah. The key thing is just understanding that the dynamic array is the reason it's a double pointer is because it's pointing to an array of pointers. So the data type inside this outer array are pointers, which is totally legal. You can have an array of pointers, but we need a double pointer to reference that.
It points to an array of pointers, and each element in that points to an array of ints, I guess.
Yep. Exactly. All right, cool. Let me go ahead and clear this out. So that was, I think, all you guys need to understand from that. So we can go ahead and move to const. So I think that's the next stuff in here. So is that like memory leaks and cool. Where was I? Okay. So const stuff. This stuff is relatively straightforward. So there's like 3 different like types of const that I'm basically going to go over. The first one is like the most straightforward, where if we just had a like const and then x equals 10, the whole idea behind making x const, which I think I already have an x, so we'll just call this variable. Oh my god. Okay, so variable, if we set that equal to 12, this is obviously going to yell at us because variable is constant, and we can't modify the value, right? So that's the whole idea behind const. So let's go ahead and take a couple looks at it within like class stuff. So we can have 3 different consts. So this is a function, right, that has a const in 3 different spots, and each of them means something different, right? So going over this, this is the first const on the outside. This is making the return type of this function constant. So whatever this function returns, that value is going to be constant. Where this gets a little bit weird is that you actually need a constant value capturing this constant for it actually to remain constant. So like kind of what do I mean by that? If we had this where I don't know, oh, because I made that a reference, which I don't need to do right now. Comment this out. So if I went ahead and did something like this,